afternoon, good evening, wherever you are. I shall be your tutor for this lesson. In this lesson, I will be walking you through a very simple but powerful electrical design software that you can use for your electrical instrumentation and control design projects. The name of the software is Simurelay. Simurelay is a simulation and design software designed by Mordi Studio, an electrical software company in Korea. This software is both a Windows and Android-based software that can be downloaded from Google Play Store or Microsoft for free. Let's get into it. In this short tutorial, I will be showing you how you can make a design just like the one that you can view on my screen. And I'll be walking you through how you can equally run this design just like the one you have on the screen. Let's get us familiar with the Simurelay work area. On the Simurelay software, we have a ribbon at the top of the software where we have the library, the play, the value, the view, hold, delete, front, back, the rotate, the capture, and to the left hand side we have the component ribbon or the component widget where we have the text. Once you click on this, it moves to the test area, to the work area, so you can click on several components from the component widget area. And you can delete this from your ribbon, your delete ribbon. Now let's walk through each of the ribbon. On each of the ribbon, we have the text ribbon, we have the source arrow, we have the destination arrow, we have a component that can be used in connecting 2 points, connection of 2 points in 90 degrees. We have a phase sequence relay, we have signal lamps, we have flashing lamps, we have the power source, which is the power phase, line 1, line 2, line 3. We have another power phase of the power source, line 1, line 2, line 3, and neutral. We have the power phase, line 1 only, line 2 only, line 3 only. You can go through the whole thing. We have the buzzer, we have relay coils, we have the contactor coils, we have the latching relay, or what is called the impulse relay, and we still have the timers. Unfortunately, this version of Simurelay we are using for this tutorial is the free version. You can see the timers are grayed out, meaning if you want to use the timer in your design, you will have to pay for this. Now we have as in contact, changeover contact, we have contact of normally closed, normally open, we have push button, we have selector switches, we have emergency stop buttons, we have breakers, almost every component that you can find in a typical design software. We have overload relays for electric motor, you have electric motor, 3-phase electric motor, you have motor for start delta design, we have single phase motor, DC motors, and a whole lot. We shall be looking in depth into each of the ribbons. For example, we are going to be looking at the library ribbon, and on the library ribbon it's where you have your components, just like I said earlier, where you have all your components widgets that you can use in your design. Quickly, we are going to do a very simple design just to be able to explain each of this ribbon. Quickly, I will click on a source here. We are having 3 sources here, which is line 1, line 2, line 3. This is a source. You can increase it You can decrease it using the scroll of your mouse. You can rotate it. So I'm using the rotate ribbon now to rotate. Just click on the rotate ribbon to rotate it. You can see I have line 1, line 2, line 3. Now stay on the library. I will bring in a breaker to have a breaker between the source and the motor. So this is a contactor. Let me look for a breaker. Now I have a triple MCB breaker here. Click on it and it imports it to your work area. You can see it's now in your work area, and if you notice, you will see there are grids. There are grids that helps you to be able to position your components properly. Just you can see this grid has positioned this almost directly. And if you are going to connect two components, all you need to do is click on this point and click on the other points, and those components are connected. Click on this and this, they are connected. Click on this and this, they are connected. So I'm still on the library. I've imported from the library widgets the source. I've imported from the library widgets a breaker between the source and the load. Now I'll be bringing in as in another component, which will be probably an electric motor. Now I'm bringing in an electric motor, a triple electric motor. You can see once you click on it, it takes it to the work area. Then you can drag and position it wherever you want. Now from this, you can see I can connect it again the way I've done by clicking on this particular one, these two, and clicking on this. I'll click on 4 and click on V1. I'll click on 6 and click on this, and you can see they are all connected. So this is the example of as in the library widgets being imported into the work area. And on this, you can see from the library widgets where we are having as in line 1, line 2, line 3, I can give them values. Now if you want to give them just like a source for someone that doesn't understand what you are doing, you can just click on this and you go to values. Once you go to value, you can see it's asking us to enter a comment. So the comment, I will just say something like 230 volts AC source. So equally I can do that for the other one, which is the breaker. Click on the breaker, go on value. Once you click on value, you can put it there. Let's assume this is a 32 amps triple breaker. I can put it at 32 amps 3 PMCB. So you can see now equally on this, see on the value, if you should look at, you can see it has something called number. Now you can see we are having this as Q1. If you click on this, it will change it to Q2. So if you have more than one of such breakers, to be able to differentiate them, you will use the number value to be able to change them from 1, 2, 3, 4 to whatever numbers of breakers you have there. Now on the third one, I can click, I will go up to value, and I can now put this one as probably my pump 1, and you can see it as appear as pump 1 or motor 1, whichever one you choose. And that is it for value. You can view. If you click on view, it takes you to the view area where the ribbons disappear. Then you can go back to the edit, which takes you back to the front area. Now you can equally click on the play. If you click on the play takes you to the simulation. You can see start simulation. It takes you to the simulation area where you can simulate your design. For example, we have a source here. You can see this is red, this is the yellow, and this is the blue. By the time you click on the breaker, you can see the motor is on. It has shown a yellow telling you the motor is on, and you can see these ones are now having red, yellow, blue. You can equally click on the breaker again, it will open it up. Then you can stop your simulation and continue with your design whichever way you want it. you can change your design from you can change your design to the light mode or the dark mode. Just click on the three dot button to your extreme right and choose either your dark mode or your light mode. Like I said earlier, the library are the list of the electrical component symbols, just like we have it on the pan here. We've talked about the play, that the play is used for the testing and troubleshooting of the design, used for the testing in terms of simulation of your design to be sure if your design it's proper, if it's working well. And like I said, the value is used, the value here is used to assign names to symbols, just like you've seen us doing. You can equally use value to assign variables to some components, such as timers. You can assign the delay time, either the delay on time or the delay off time, to timers. We equally use them for tags. I will continue with this design, and in this design I will be introducing an overload relay. Let's see that. I will be taking this one off. I click on that, I click on delete, I click on this, I click on delete, I click on the third one, I click on delete. Now I want to bring in an overload relay. Now you can see this is the overload relay, and with the help of the grid I've been able to position it so that it can align with both the breaker and the motor. After which I click on each of those terminals to connect them. You can see me connecting them. Now after this connection, you can see that this is saying this is F1. This is F1, which is the overload relay. Now let's go back to our play and see if we can simulate this. From the play tab, we close on this and you can see the motor is running. I'm opening the motor, I'm going back again. Yes, I want to help us to understand how we use the value tab, how we use the value on the ribbon. Now from this design, you can see an MCB is a mechanical device that requires a closing or opening operation by an operator. Just a closing, a mechanical operation to be able to close or open. An overload relay, it's equally as a mechanical device that allows currents to flow, though the opening of this depends on some condition which must be met, probably if there's an overload on the system. Now, but to be able to understand the value tab, I will want to take this out. I'm deleting it. I will be bringing in another switch, which is a contactor. A contactor is an electromagnetic device that requires power supply to be able to close or open. So I bring in a contactor. You can see I'm positioning it now. I'm connecting the contactor between the motor and the breaker. I'm connecting the contactor between the motor and the breaker. One thing with contactors are you cannot close contactors without as in powering the coil of the contactor. These are just the contact of the contactor. Let me go back to play. From play, if you close this breaker, you can see the breaker was closed, the MCB breaker was closed. Power gets to one of the terminals of the contactor but could not get to the motor because the contactor requires a signal on its coil to be able to close. Now I'll go back to the design software. To be able to close this contactor, we need to bring in a contactor coil. So from our ribbon, let's look for a contactor coil. Now this is KM contactor coil. You can see. So we now have a contactor coil. I've positioned the contactor coil as such. Now to power this contactor coil, we require a source. As in either a control source. Now I'll be bringing in let's say, okay, let me bring in a negative. Let's take it that we are controlling this using a DC supply. So I've connected this to the negative. Now we need to bring in the positive on the other end. Now you can set the positive. I'm going to rotate this. So this is the positive. Now between the contactor and between the positive of the contactor and the negative of the contactor, I will introduce a control breaker in between. I will introduce a control breaker, or probably a push button. Let's say a push button. It's a push button. Let me see. Will a push button be good? Okay, let's introduce a switch, a selector switch. And you can see I'm introducing a selector switch. So in between, now this is a 3-position selector switch: position 1, position 2, and position 3. I'm connecting the positive of this to position 1, and I'm connecting the A1 of the relay to position 3 of the selector switch, meaning anytime I power the selector switch, this will have to change. This will have to change. Now let's see. Let's go to our simulation software and see. I click on play, and you can see there is power here, but because this is still open, now let's see. I close this. The KM1 is still opened, so let me change the value of my selector switch. You can see power has flowed through the KM1 and it has started the motor. Now I'll go back to my design tab. Now on my design tab, I can click on this and click on value. You can see on value I'm having numbers, meaning I can change the numbers. I'm having terminals. You can change the terminal number. You can see we have 1 and 2, which is the one in blue. 1 and 2 and 4. You can change it to 11 and 12 and 14. You can change it again to 21 and 22. The reasons we have this is there are occasions where we need to use a selector switch and we need to use more than one. So in the nomenclature we use 1 and 2. Then the next one we use 21 and 22. In another auxiliary of the same selector switch we use 31 and 32. And that is the purpose of the terminal. So to be able to differentiate if you have more than one. For example, let me bring a contact. You see this one said contact number. Now on contact number you can see it comes as K1. The contact can be a contact of a relay, it can be a contact of a contactor, it can be a contact of an overload relay. So if you click on this and you go to the value tab, from the value tab you can see we now have a third one which is saying the tag. If you click on tag, you can see by default it is K, which means the contact of a relay. You can change this from K to KM, which is now the contact of the contactor we are using. You can change it to KT, which means it's now changing it to the contact of a timer. You can change it to S. You can change it to F, which is talking about the contact of an overload relay. So anytime you have a contact being used, you have a third one which is the tag, and you can change the numbers based on the numbers of such contact you are using in your design and the terminals. For example, in this design, let me quickly do something on the design. From the design now, if this is this, I click on this, I go to value. From value I go to tag, because I'm using KM1. Then I will change this, I will look for KM, which is now the contact of this relay, the contact of the contactor. So this is KM1, so this is KM1, which is the contact of the contactor. Now with this, now let me bring in another component. Let's say a lamp. Let's look for a lamp. Now I'm bringing in a lamp. I can position a lamp somewhere here. Then from here, let's connect the lamp with the negative. So we can see we've connected the lamp and the negative together. Now let's connect the contact of KM1. with KM2 and with the lamp. You can see we've connected this together. Now let's connect this to the source. You can see we've connected this to the source. Now with this connected, now let's go back to our simulation and see. So we go to play, and you can see even without switching on this yet, already we have the positive supply getting to this place, but the lamp is not yet on. Now at what point will the lamp be on? Now let's click on this. Immediately you click on this, you can see KM1 is energized and the lamp comes on. The motor is on here, so I can switch this one off. The motor goes up, I turn it on, the lamp comes on and the motor goes on. Now let's go back. Now we assign on the value KM1. Let's change this KM1 to something else. Instead of KM1, let's go to tag and change it to something like K. Let's see if that will work. We have given it another tag, which means it now has another meaning. Now let's go to this. Let's see. We turn this one on. We turn this on. You can see the motor is running, but this is not running. The lamps are not on because the KM1 does not recognize K1 as its own auxiliary. It's recognizing it as another thing entirely, and that is why it's not working. Let's go back again. Let's change from the value tab. Let's change it back tag, and let's go back to KM. You can see it has changed again to KM1. Let's go back again to the play, and let's see if it will run now. We can see. I think we now understand how each of these tabs on the ribbon works. In our subsequent video, I'll be walking you through different electrical instrumentation and control design, like water treatment plant control, automated transfer switch design, and simulation of various motor starters like the direct online starter, the start delta, and the auto transformer starter. This is just an introduction to instrumentation design and control, and just to make you understand how the Simurelay software work and how it can help you in your design journey. I want to say thank you on this note for staying tuned with me. We'll meet in our next class. Thank you.